Sometimes a question demands more than just formulas. It demands your patience. Especially the questions from Combinatorics test your patience. It challenges your counting skill. So you sit with the question, staring at the black letters and the numbers printed in the question, is scribbling pages after pages to get a single clue or maybe the solution of the question. But 10 to 15 minutes goes by, still no clue you get. But you don't give up. And finally a spark, a breakthrough. And that is the beauty of problem solving. The persistence, the time you invest in this whole pursuit will pay you back. The persistence always pays back with the reward of a solution, and sometimes an elegant one. Welcome to a new video. Today I have brought you a question from Basic Combinatorics. This question is from sample paper released by IIT Kanpur most recently for JEE Advanced 2025. So here is the question, as you can see on your screen. There are 9 balls, number 1 to 9, are put randomly at 9 equally spaced points on a circle. And let S be the sum of absolute values of the differences of the numbers of all 2 neighboring balls or consecutive balls. The number of ways such that S has minimum possible value is. So this is the question we have. You want to give a try, you can, before watching the solution. And I feel the question is very wordy, but believe me, it's solve worthy. So let's solve it. Alright, so here we have the question, and we have to first understand what the question is saying. It is saying that I have 9 numbers, and these 9 numbers are attached to the balls. Means all the balls are numbered like 1 to 9, so it doesn't matter you are considering the ball or not. So let's say the balls are here and each numbered through 1 to 9. So in that way I have taken this arrangement, and they are saying that S is a symbol which denotes the sum of the absolute value of the differences of 2 neighborhood numbers. It means if I take this S, I have to take the absolute value of 1 minus 2, because 1 and 2 are the consecutive or neighborhood numbers. 2 and 3 are again the neighborhood numbers, and so on. So if I add all them, and finally also you have to take 9 and 1, because these are also neighborhood. So if you start from 1, you complete the whole cycle till 9, and you have to find each gap, and you have to measure each gap with the absolute value and add them up. That is actually S. They're asking that in how many ways that S can be made minimum. So let's say I have this arrangement, and let's first find that what is the minimum value can be possible. So if I have the gap 1 between 2 consecutive numbers when we place, there is a chance that we can get minimum. So if I take like 1, 2, 3, 4 like in this order, and I'm taking this in anti-clockwise order. So if I take this gap is 1, 1, 1, 1, 1, 1, 1, 1. So this, all the gaps values will give you 8. Now there is one gap here, 1 to 9, and that gap is 8 because the difference between 9 and 1 is 8. So altogether the sum I'm getting 16. Now the point is it possible to get the sum less than 16? It's not possible. Why so? Because in any way, if you just rearrange or any little disturbance if you make, the sum will exceed the value 16? Because this gap is already, I have 8 from 1 to 9 in this direction, and from 1 to 9 in the other direction is also 8 if I write all these numbers in increasing order. So because each gap between two consecutive numbers, if you write in increasing order, is 1, there is no chance to get minimum than that or the lesser than that, and this is certainly going to be 8. So if you want to give a check whether it is possible to get the number less than 16, let's make some changes in it and see what will happen. So my first claim is the sum minimum is going to be 16. So here you can see that again I'm starting from 1, but you can observe these two numbers. I have changed these orders. So my claim is the sum of gaps, if you take, this will exceed 16, and let's see how. You notice that this gap is 1, so let me write it. This gap is 1, but this gap is 2, and this gap is also 2, and all other gaps are originally what they were actually. So this is now 8, this is 1, this is 1, and this is 1. Now count them, then add them. So 2 plus 1 3 plus 1 4 plus 1 5 plus 8 13 plus 1 14 plus 1 15 plus 2 17 and 1 18. So we got this sum more than 16. So the first claim was the minimum value is 16 only, and the second claim at the same time is we're starting from 1, the number should be in increasing order only. So how we can understand the whole scenario to get this 16? 16 is the minimum value, we cannot get lesser than 16. So how can we get it? So my take is this. Let's understand and observe this from the basic. So what I'm doing, I'm just placing this 1 here and 9 there, and I'm assuming that between 1 and 9 there is an arc, and on this arc I'm going to place any number from 2 3 4 5 6 7 8. Let me write it. So I have these 7 numbers: 2 3 4 5 6 7 and 8. Now if you are not choosing any number from 2 3 4 5 6 7 8 between 1 and 9, so this is one case. It means on this arc I am not choosing. Or we can think in this way also. First I am taking 1 and 9 here only. There is no gap between them. So this is the only one possible arrangement in which the sum could be minimum. So in this first scenario, when there is no gap between 1 and 9, I have only one possible case, because I have to write all these numbers in increasing order only starting from 1. Now what I'm doing that, I'm just taking this 1 there only, but I shifted the 9 there, means 1 unit away. Now my claim is, because if you choose any number between them, the gap is still 8. Suppose you are giving this ball to the number, let's say, I don't know which number you want. I have no facility to ask you which number you're thinking. So I'm just taking randomly 5 there. Suppose I'm taking this 5 there. You can think still this total gap is 8 only. Do you think that? Because 1 to 5 is now 4, yes, and 5 to 9 there is 4. So total gap is 8. So I have to maintain this gap is 8, and it is already maintained by just taking any number. Now to make this thing 8, to make this side 8, I can write the possible order in increasing only, because we're starting from 1. We cannot choose any random positions for the remaining numbers. It means, suppose I have taken this 5 there, I have to write the remaining numbers in increasing order. So I have to take 2 there, then 3 there, then 4 and 5 have already taken there. So 6, 7 and 8. And why it is happening? You see why it is happening? Because this gap is now 1, this gap is 1, this gap is 1, this gap is 2, this gap is 1, this gap is 1 and this gap is 1. Now count this thing, because 1 plus 1, 2 plus 1, 3 to 5, 6, 7 and 8. Because you are taking that number this side, so this is 8. The remaining things, if you put in increasing order, they will balance to get again 8. You can think of the same thing with the different numbers at the place of 5 there. So this is the idea. So in the second case, what will happen? In the second case, I will have only 7 choices. Why? Because I can choose 5 there, I can choose all the remaining 6 there. So total number is 7. Now you may think that if I'm choosing this 7, I can also write the 7, choose 1 there, and this side any of no. Because once you choose this 5 there, automatically the remaining will go in this other arc. There are no other possibilities for them. So they will automatically go, and of course the arrangement is not possible because you have to choose them and put in only one single arrangement. There is no choice of permutation. Therefore there is only 7 cases in the second part. The third part I can do now is the third case, or you can say, again I'm putting there 1, and I'm now keeping 2 values between 1 and 9. Means I shifted this 9 this side at this position. So again, out of this 7 values, 2, 3, 4, 5, 6, 7, 8, I can choose any 2 there. Let me take an example. Suppose I have these numbers 2, 3, 4, 5, 6, 7 and 8. So I choose there, let's say 6 and 7. I don't care. Now count this value. This value is 5, this gap is 5, this value is 1 and this value is 2. What is the total gap there now again? This is the observation. This is 8 again. It means to maintain this side 8, this order 8 or this direction 8, I have to again write the remaining terms or remaining numbers in the increasing order only. So what you simply do for this case, for this third case, what you can simply do is, out of 7, any 2 you are choosing in this places. Which 2 places? In this arc. Any 2 you can choose from 1 to 9 in this direction. So if you choose any 2, it means the 7 choose 2. And 7 choose 2 will give you 21. Now again there is one thing. You cannot arrange them in different order. Why? Because if you take 6, 7 in this order, that will give you 8. But if you take 7 and 6 in the other order, what will get? Just think. This will give you 7. This will give you 6. So what is the value you get? This is going to be 6, then 1, 7 and then 3. That will give you different values, not 8. So in that possible cases, or that possible numbers, we can make the case 3. Alright, the case 4, now you can think what will happen. I am taking this 1 there only, but I am shifting 9 there. So now I have 3 choices, and out of the 3 choices, you know that what will happen. For that, I have 7, choose 3, and that will give you 35. Now, is there any other case possible? This is possibility there, but you see that if I choose 4 cases, if I shift this 9 there, let me just take it here. What I'm going to say that, suppose I'm taking 1 there and 9 there, and I'm taking 4 values. There's 1, 2, 3 and 4. This time I have to choose 7C4, and this will give you other 3. It means is the replica of the 4th case, but in reverse direction, because 7C3 is 7C4 also. So I don't care if we are finding the reverse direction. Why? Because we can copy this twice. So if I'm intended to find out the anti-clockwise and the clockwise different, I can simply count till here and make it twice, because after that all the cases will be the replica of its corresponding previous case. So for third case, I can say the 7 choose 5 is the replica or the other reverse direction arrangement. So far we have done this thing, and that thing we have to just add up. So we get the sum, I mean the total number of ways, not the sum. So total required number of ways. So the number of ways required is 1 plus 7 plus 21 plus 35. So I believe this is 29 plus 35, and so the answer is 64. So there is 64 in which we are taking the anti-clockwise direction and the clockwise direction arrangement as the same. But if the question asks that the clockwise direction and the anti-clockwise direction is different, we have to multiply this answer by 2 and you get 128. So this question originally is from the sample paper, as you know, but it is from the single correct answer. So I will go with the 64 because I assume that the question is asking for the case when the anti-clockwise and clockwise are considered to be the same. If they ask for the different, I will also go for 128. So if the multi-select, and if this is the ambiguity in the question, they are not clear about the anti-clockwise and clockwise, I will go for the both of the options. So my choice is 64, and some other can consider that it is both, so we can say 128, or anti-clockwise and clockwise both is considered, so in that case 128. So this is the way to think this question, and I hope you liked it. See you in the next video with some other problems that I think you must try. Stay math active.